All right, let's get started. This is Xiaohua from University of Science and Technology of China. So for this section, we'll be going over the GMT vector plots. We'll be basically plotting geodetic data like vectors, grids, and other stuffs in this session. As you can see that we are having this page over here, which have listed a bunch of stuff that we'll be using or we'll be playing with for this session. We'll be mainly using the GMT reload command, and together with that, the -SE option for plotting vectors. There are a bunch of attributes associated with the -SE option, and we'll be going through them one after another. So let's waste no time and get started. Stop share. And there's the other tab. All right, here's the VSE. As you may see on the left side, we have all the data that is needed for this session. You can download it from the link provided by that GitHub page, which is a Google Drive link. Basically, after you have like unzip them, you see a DE and DN and new falls and ridgecrest, these kind of data set. They will be used for the second session or second part of this session. At the very beginning, we'll be starting by playing with some of these vector attributes as we just talked about. So let's waste no time and get started. We want to get a new script. We'll be using GMT --new script equals bash, and we will be outputting it to plot vec.sh. And now you'll see that we have a script here. We also want to make it a executable. So it's plus x plot vec.sh. Now, if we open that, you see that you have a basics of a GMT script. You probably need to specify a session name. Maybe we'll just call it 11th over here. And of course, we need something to plot. So let's try with the echo command. We'll be doing, for example, we wanted the vector to start at 0 and 0. And it has the eastward and northward motion to be 1 and 1. And with a small uncertainty, that's about 0.2 and 0.1. And the last column here actually is the correlation between the two direction. Here we're setting it to 0, which means the motion in two directions are actually independent with each other. And after that, we're gonna use the magical pipe command and pipe it into GMT. Basically, it's using the output here from echo as the input for GMT below. And we want to use the -SE option. And for this -SE option, it comes with 3 attributes. One is the scale. Or here, we want it to be plotted as just full scale. So I'm using 1.0 here. And for uncertainties, you need to give it a confidence level. Here's 0.65, which means 1 standard deviation. And the last one, actually, I think it's a font size, which may or may not show up depending on whether you have text for it to plot afterwards. And then you want it to be having the pen width being about 1 pixel. But you may have realized that we haven't set up the projection yet. So why don't we just set JRB equals -J, because this is vector is 1, 1. Let's wrap this vector with just a 1 in distance, size being 3, 3, and -R. Let's try -1, 2, 2, and -1, 2, 2. And for the frames, let's use default AF1, AFG. Then let's call this variable over here $JRB. And now we have a script, but we still have something to set up. GMT begin a figure name, let's just call it vectors. A vector. In format, we want it to be PNG. We don't want it to show up because I'm sharing this window. It's not going to pop up on the screen. Now let's save this script and then run it over here. And oops, something's wrong. Oh, I forgot to specify the projection. Here we want it to be a Cartesian, so let's use X. And run the command again. Now we have a little plot over here. If we bring it up, this is how it looked like. Let's make it a double column and close this one. And yeah, it's a little bit too small for this plot. So let's make things just slightly smaller. And to another line. All right. Another thing that I want to mention here is that some of the systems have a different default projection unit. Those can be actually changed. For example, GMT set, PROJLENGTH, which is length unit. For example, if I want to change it to inch, and then you run this one more time, you see that things changes a little bit. That is because the default is actually centimeters. Whichever way you want it, both are fine. But if you find that your plot are different from what I'm showing over here, it's probably because of this reason. You can change this projection length unit, and then things should be okay. So now we have a little vector, and with its uncertainty circle, what are we going to do next? We mentioned here that we're using one standard deviation, but what if we change this confidence level? Let's change it to 0.99, which corresponds to 3 sigma, which is 3 standard deviation. If we save the script and plot it one more time, then this circle grows to like 3 sigma. The next thing that we're gonna play with is this correlation. For example, over here it's 0. If we change it to 0.5, which means it has some correlation. If one error increases, the other might increase as well. Moving toward one direction. Then if we save the script and run it one more time, you see that the shape of this eclipse actually changes a little bit. Next, we're gonna play some attributes with these arrows. That is actually mainly controlled by this -a option in this below command. There are many of them. For example, I can change the size of it, which is 10 pixel. If we save the script and run one more time, you see things become really, really tiny. So let's change it to a slightly larger one, about 20 pixel. Things doesn't change. Where's the arrow? That is because we didn't tell it to have an arrow here. If we try a plus E, which means at the end, and A, which means a fancy arrowhead, and we run this plot back one more time, you see, we have a pretty big arrow here. Of course, you can add more attributes to this -a option. For example, at the beginning, we want a tail. You just give it a plus BI. You save the script and run one more time. Then we have an arrow tail at the beginning. We could also change the color, of course, using the plus G option. Let's see, we want it to be red. Then if we save the script and run one more time, you'll see, the arrow becomes red. And also its tail. And there's another option that I kind of feel that this arrow is too wide. I want it to be narrower. Then what you can do is to change its angle, which is the plus A option. For now, it's probably something like 30. How about that we change it to 15, which is half. And save the script and run it one more time. Oh, things become narrower, looks better. And there are other options. Again, if we want these outlines of these arrows to be a little bit thicker, you can actually add a plus P option here. For example, here is actually default is 1 pixel, I think. If we change it to 3 pixel, and then we save it and run this one more time, you see that the outline of these arrows are becoming thicker. We also have this -W option at the beginning, but this option actually changes, or what it controls is actually this ellipse and this line that connects from the beginning to the end. Let me change this a little bit so that you can see it more clearly. If we use a slightly thicker 5 pixel, and I don't want this black color, I want it to be blue color. And if we save this and run this one more time, okay, now the arrow body and the ellipse becomes blue. And there's another option, of course, associated with this -A. If we want to only plot, for example, half of this arrow, we could add a +L or +R to plot the left half or the right half of this arrow. And if you save the script, plot it one more time, you see here is only plotting the right half of this angle, of this arrow. I think we have pretty much gone through all the attributes associated with this arrow plot. And there's a bonus challenge, apparently, which is asking you to plot a double couple symbol, which should be very simple. You just switch between this L and R with a plus -Y or -X option to shift it a little bit. Then you need to choose whether this arrow needs to be at the end or at the beginning with this -C and +E and +B options, which should be fairly simple to do. Okay, that's pretty much everything here. And there's another option. Actually, you can color your arrows with a color map. Instead of making it a fixed color, you can actually use a color table to color these arrows. I'm going to show you guys how to do that. Let me close this. We're going to start with the GMT. Well, let's just copy this script. Plot vec.sh to plot vex.sh. Now we have another one here. Let's open that. And again, we're going to change this name to maybe vectors. It'll be a PNG format again. But we don't just want to plot this one line. We want to plot maybe a couple of them so that we know, depending on whether, for example, their lengths, we're going to color them differently. So before we start this GMT, let me copy this line 3 times. So we'll be plotting 3 arrows. The first one will be starting from 0 and 0.5. And the length will be 0.5 and 0.5, with the uncertainty being 0.1 and 0.1, some correlation, maybe 0.5. And the second one will be the one that we just plotted, which will be starting from 0, 0 to 1, 1. Let's say it'll be 0.2. Correlation will be, I don't know, negative 0.05. The last one will be starting from negative 0.5 to, with the length of being 1.5 and 1.5. Let's say that this will be 0.3 and 0.2. Correlation being, let's say, 0. But we want to store these. So how are we going to store them? So we're going to redirect it into a file, let's call it temp.dat. Then we're going to append to that file, which should be double redirect, temp.dat and temp.dat. The next, when we are calling GMT below, we will not be using that pipe. We'll be directly using temp.dat here. Probably we don't want a very fancy arrow over here. Let's say just the most simple ones right here. And we want a 1 pixel, for example, black. Oh, we don't want it to be black yet. Let's see how it goes. Plot wax.sh. Yeah, it ran. Let's open that and make it double column. It's slightly smaller. Because we're plotting 3 sigma, that confidence level, these circles are a little bit too big. Let's change it back to 0.65. And the arrowhead is a little bit too big too. Let's change it to maybe 20 pixel. Save it. Plot vector. All right, we have 3 arrows. But we want to make up a color table for it to use before we really tell how to use it to color the arrows. We'll be using GMT, make CPT. Let's use rainbow, maybe. I mean, you can use jet or whatever you want to use. Minus T. Since the length of these arrows are actually ranging from, I don't know, 0.5 or 0.7 to maybe 2.5. So let's try to make it from 0 to 3 with a increment of actually, it's about 2.5. So let's make it 2.5 with 0.1 and minus C, minus D. This is for saturation and continuous color map. And let's output this into wec.cpt. And then next, we will be using the minus C option. For example, here, wec.cpt. And now if we save this and run this one more time, you see that it's colored with different colors. It's only the arrow part. If we also want the lines to be colored by this color map, you probably also need a plus C here with the minus W option. If we save that, run this one more time, now see that all these parts are also colored with these colors. That's pretty much everything for this part. Of course, if you want a color bar, you can just add a color bar. I mean, I know it shows up on the example, but I'm not gonna plot it over here. All right. Next, we will be moving to the part where we'll be playing with some actual data, which will be the GNSS data for the Ridgecrest earthquake. Let's close these and this. All right, we'll be again using GMT minus new script equals bash. Let's call this plot map.sh. Let's change mode plus X, making it an executable map.sh. Now we have a script over here, and we'll be opening that. Again, we'll make up a session name called 11. I don't know whether that's required. But before we really get started, we'll be playing with some of the variables. The good part about setting up variables is that if you are going to use that frequently afterwards in the script, later on, if you just change the variable, it'll make it much easier to change the script. So over here, we'll be setting up a few of them. For example, let's set GPS, which will be the data that we're playing with. Let's call it ridgecrestgns.dat, which is basically the file name over here. And also RR, which will be the projection or the range that we'll be using. But I don't want to just try to figure out the area that I'm going to play with or I'm going to be plotting with. A really handy way of doing that is actually to run a GMT grd info command, because the files that we got from that tarball, it has D and DN, which is the displacement in east and north directions, predicted from a kinematic slip model using INSAR GNSS data. So to figure out the area to plot, we'll be using a command called GMT GRD info with the de.grd, which is one of the input grid. These two have the same size, by the way. And I'm going to use the -i minus option. Actually, -i means popping out the increment. Let's copy these and try to run it out here. We'll see what it comes out. You see that the increment is 0.01 degrees. But if I add another minus at the end, it's actually going to pop out the range information, which is the -r option. So we're going to use this output to set up the variable. Again, here is you can't use just a quote. You'll be using that little thing to the left of your #1, that button, which is actually coding this command over here, using its output to be the input for setting up this variable. And if we save the script and do a simple test, you see, let's set up the file name just for the moment. And we don't want it to show up. If we save this and then run plot map.sh, you see that it actually pops out this RR. This variable is set to be this output from this GRD info command. Of course, we don't need this. Then we're going to also set up the output to be, for example, demo, and also the format to be PNG again. Then we can just set up this plotting session to be $output and $format. Next, we're going to start with plotting a very basic map, which is GMT base map. Here we're going to set up a Mercator projection with a size of being 6, which is horizontal size. You just leave the other size, it will figure out by itself. And $RR and -BA. Let's try 1 degree and F.5 degree this time. If we saved script, then run this plot map. Okay, there's a new file coming out. There we go. Let's make a double column. Make this a little bit smaller. So now you have a blank map to play with. So we'll be plotting something, for example, at the background. A good choice, of course, is the DEM. Since GMT provides you with some remote files, here we'll be plotting the remote Earth relief file. Let's say that we want to plot GMT GRD image. At Earth relief. We don't want it to be like really high resolution, so let's do the 15 seconds. And we also want to shade it a little bit. For example, we want to shade it is plus NT. This NT or NE specify whether it's a linear shading or exponential, doesn't matter that much. Let's give it a 0.3. And for the color table, let's do EM2. Let's see how things goes. If we save it, run this one more time. Oh, great, we have the DM. But I don't like this DM plot. It looks too brownish. It's not great. So we're gonna tune this color map just a little bit. For example, EMT make CPT minus C EM2. One reason might be because the maximum is actually set to a smaller value, which might be 3000 or something. I don't know the exact number. If we stretch it a little bit, you see more greenness. Let's try minus 100 to, for example, 6000. and with the increment being 100, and minus d into, let's call it topo.cpt. Then when we call this color table, let's just call it topo.cpt. And if we save this and run it one more time, all right, things are a little bit more green. At least Central Valley is green. That's good. Next, we're going to plot the coastlines. I mean, there are not much ocean in this map, only the bottom left corner, but it might be good practice. We'll be calling GMT coast, and with the -n option. We probably have gone through this yesterday already. We're going to plot all the boulders with 0.5 pixel black dash dot dash, whatever that is. And for the ocean, we want it to be light blue, which is not too bad of color. It could be tomato. And then -df, which means definition is full definition. We save this, run this plot map. All right, we also have, I mean, other than just the coastline, you also have this little lake. Once you have these, we'll be using GRD vector to plot these D and DN grids. Basically what it does is actually taking out like every increment specified by your -I option, and then plot every pair as a vector on your map. So the command runs as GMT GRD vector. We're going to give it the east first and north second. Next, we're going to specify a length scale. For example, here, since we set, well, we haven't set, but well, we'll do that anyways. GMT set PROG. What's the name of that? Projection length unit. Yeah, projection length unit. Which inch. Then we're going to use the -s option to set up the scale we'll be using. If we do a GMT GRD info on DE.grd, these are the output. You see that you have the range specified here, how many number of columns, how many number of rows, and you also have the Vmin and Vx and Vmax, which tells you the range of this grid. Like smallest value is -79, and the largest value is 94-ish. We can do the same thing for Dn. Yeah, it shows about the same range, which is somewhere between, I mean, likely -100 to 100. And since we set the total length of this plot to be 6, which is the size from left to right, it might be a good idea to make it the maximum one to be somewhere around like maybe 2 centimeter. So we'll be setting the length scale to be 50i. This is basically the number that will be divided to the values in this GNSS data that'll be plotted on this map. And if we also need to specify the width. For example, let's want it to be 1 pixel for the vectors. And again, we'll be using something to control what the vector look like. We talked about that it is actually -A option for GMT below, but for this GRD vector, you have to use another one, which is -Q. Everything afterwards is the same. The reason that is -XQ is probably -A is already taken by some other options. Let's try maybe 10 pixel for the error head size. And with +E at the end, having a plane arrow. The plane arrow is just like 2 line segments. And for those that are having a smaller size, we want to normalize it. So we're actually giving it a +N option. I don't know, maybe 10 is a good number. If we save this and run this one more time, plot map. And oops, I don't know what happened. things are a little bit too big, I think. Oh, I forgot to specify the increment. This is plotting like everything. I mean, you see this little butterfly pattern, but that is because I didn't specify the minus I option. For example, we want it to be plotted every 0.1 degrees. Now, because this is essentially plotting out every single point in that grid. If we save this, run it one more time. All right, we have these arrows. I mean, you see that it looks like the whole thing is moving sort of like a right lateral motion here because the main shock is actually right lateral, sort of along this direction. In this tarball that I gave you guys, you have this new faults.gmt. If we add this file, you see that it's made up of these segments. So we'll be plotting this to sort of mark the faults. What will be plotted here is that we'll be using the plot command, new faults.gmt. Let's make it really, really thin because you probably have lots of segments in there. Let's try 0.5 pixel, and we want it to be maybe red. And if we save the script and run this one more time, now your faults are there. Sometimes you may feel that, these faults are actually above these arrows. I don't like that. Well, the way to resolve this is actually moving this line above. Basically, what GMT does is actually plotting layers and layers on top of the other ones. So if you don't like the red lines to be on top of these black arrows, then you can actually plot that first. Next, we'll be plotting the GNSS data. But before we do that, if we had this Ridgecrest GNSS.dat, you'll find that it actually has more columns than required. The reason is that this text file is actually made up of more than just horizontal deformation. You have columns of longitude, latitudes, then east, north, up, and displacement, and also the uncertainties of east, north, and up. This 0 is just some fake, not really useful numbers, but you can ignore it. So later on, when we are using this relog command, we actually have to do something first. The way we do that is that we use this awk command, which is pretty useful for shell scripting. We're going to print $1, $2, which is the longitude, latitude from this data, and $3, $4, which is east and north displacement, skipping 5, and $6, $7. Now we have long, lat, east, north, and uncertainties of east, north. Then their correlation. Let's assume they are just not correlated for the moment. And this is printing out 0. And then you give it the file name, which is $GPS. Basically, now you have a table. Next, what we're going to do is that we're going to redirect this using this magic pipe it into GMT below. Let's start a new line here. We're going to use, again, the same kind of option to be 1 pixel. Because we want it to be a little bit different from the background arrows, let's make it blue. And then with the -SE option, in order to make these output match whatever shows up here, because this -S option uses length scale. But remember that when we are playing with the vectors, what is shown here is actually the scale that will be multiplied. For it to match the 50, we're going to use 0.02, which is basically 1/50. And the confidence level to be 1 standard deviation. And for the font size, we just use 10. With the -A option for the arrowheads, we're going to use about the same 10 pixels. Plus E, now we are using a fancy arrow so that it looks a little bit different. And we're also going to normalize it with 10. If we save this and run it one more time, oops, cannot find file W1P blue. Oh, I'm missing a minus, sorry. Save it. Complains a little bit. topo.cpt GRD. Yeah, whatever, just run it one more time. Now things are going. It's probably like it didn't finish previous one properly. You just run it one more time, everything works. Now we have all this GNSS data over here. But it looks a little bit different from what is plotted. Oh yeah, I think I forgot to specify the arrow color. Let's try G black. All right, it looks a little bit more like what's shown up on the website. Now we pretty much have everything that's listed on the website. What you guys could be adding to this plot are like the epicenters and the line that link to a focal mechanism that's just shown by Dongdong. Actually, there's one more thing that I'd like to try here, which is plotting like drawing out a profile from this deformation field or displacement field. And the command that will be running that is actually called GRD track. But before that, we want to make sure we know where we'll be tracking the displacement field. Okay, here is pretty much where the epicenter is, which is about 35.75. And we want it to be spanning from maybe negative 119, which is 190 west, to maybe 116.5. So the command we'll be using is, let's plot this line first. Plot, well, we need a file to be plotted with. Let's echo negative 119, 35.75 into temp of the DAT. We're gonna need another part, which is negative 116.5 to 35.75. Double redirect temp.dat. So we're plotting this first. Temp.dat minus W, I don't know, let's make it a little bit thick so it's sort of apparent about everything's there. Let's make it gray. I think that's good to go. Oh yeah, let's make a dash line so that doesn't cover too much stuff. If we run the plot map, you see, okay, this will be the line that will be making the GRD track. Then next, we're gonna run GMT GRD track. If we don't want it to make things really, really complicated, a simple way of running this command is to use -E option. Then you give the line segments in couples of numbers. For example, you want it to start from here, separated by slash, and I want it to end here. So from west to east. And the attributes we'll be using is the +I, which tells you, okay, from this point to that point, I want a record every how much distance. So over here, we're going to use 0.01 kilometer. That means actually every 100, no, actually 10 meters, which is pretty dense. And we're also going to use +E, which means it's going to output things like with one more column that tells you the distance from the beginning point, which will also be in kilometers. If we run this command, well, we can't do that for the moment. Let's pipe it to the head so that we can check on what it looks like. We save this and run this one more time. Yeah, specify minus G, sorry. Because I tell all these parameters, but didn't tell it which grid to track it on. Minus G, let's use dn.grd for this plot. All right, these are the output. You see that you have the longitude, latitudes, and also the, I think it's the displacement. I think it's a distance, and then the displacement. So what we're going to do is that we're going to continue this pipe command, but change it to awk. Let's make a new line first. We'll be printing out $3 and $4, which would be the distance and the deformation. We're going to, again, pipe it to plot. We'll be using minus JX, which is Cartesian. We want the width to be the same or about the same at the width of this plot. So we'll be using 6 over here. And for the other size, we'll be using 2. So it'll be a rectangle box. And for minus R, because we discussed before that the size of that is about like minus 100 to minus 100 to 100. I mean the maximum and minimum values. But we also need to determine the range of how long this profile is. If you think about it, I mean 1 degree is about I don't know 100 kilometers. This is about like 1-2 degrees, but it's a little bit northwards. So let's try 0 to, I don't know, I'm just making up numbers, 120 kilometers. Then we're going to specify a little bit more parameters, like how thick this is. We want it to be magenta, maybe. And we don't want it to be plotted on this plot. So we will shift it by, I don't know, 7.5 inches. And we're also going to label this plot minus BX AF G plus L, which is label. Distance, it's in kilometers, and a minus BY AFG plus L. This will be displacement. It's running out of space. It'll be in centimeters. So if we save these and run this one more time, something didn't get found. Plot, yeah, should be GMT plot. If we save it one more time, something isn't correct. Yeah, like I said, no, it's not running. Not producing. Topo.cpt is empty. Am I using topo.cpt? Oh, cannot find file. I'm missing this minus again. Yeah, it happens. Run it one more time. Yeah, it's going. Now you have a plot and with a track over here and the deformation profile on top of it. I think that's pretty much everything. We have some bonus challenges listed on the website, but feel free to plot for any other data set. If you just Google UNACO event page, let me try to stop share. Try to share again. And all right, getting interrupted a little bit. So if you just Google gauge geophysical event response page and click on the top search, you'll be redirected to this geophysical event response from the EarthScope consortium. And down below, you'll find a list of past earthquakes. For example, the, I don't know, Oscar earthquake from the year before, I mean, 2020. If you want the data, just click on it and you'll be redirected to this page. And down below, you should be fine. Okay, the gauge GPS GNSS displacement estimates are available. If you just right click and open it, you'll be redirected to an FTP site. Then you can actually open it and try to download data. I'm not sure whether this is still available after like things are being converted to this new website. But before, you can actually download things as a guest. Feel free to play with it with these data sets. That's it.